Hi. Hi, everybody. Welcome to this talk about how to turn your Kubernetes cluster into a castle by using advanced Cilium Network Policies. First of all, I will give you a brief introduction about the demo use case I built for this specific talk, followed by some general guidance about how to secure your nodes in case you actually want to do that with a Cilium kind of native approach. Then I will talk about how to secure your infrastructure components that are running on top of your Kubernetes cluster. And last but not least, I will try to explain how you can build a default policy, a network policy rule set for your user workloads. To be more specifically, for your namespaces where the user workload is running in. So my name is Philipp Schmid. I'm a solution architect at Isovalent, based out of Zurich, Switzerland. And there I'm part of the customer success team, mainly helping existing customers succeeding in their Cilium journey and getting them to prod. So let's first talk about some anti-goals of this talk. So this talk isn't a network policy 101 talk, and this talk is also not meant to show abstract network policy design patterns. And beside of that, I would like to, of course, mention what the goal actually is, and that's to show you a practical example how you could secure your Kubernetes nodes, cluster, workloads on top of this cluster by using advanced Cilium network policies. I built, I would say, rather common architecture of, here in this case, kube-apiserver-based Kubernetes cluster. And as you see, there are also some widely used infrastructure components, such as Cert Manager, Nginx Ingress Controller, and the Prometheus stack, including Alert Manager and the dedicated Grafana installation. So I would say probably 95% of you all are probably running at least one of those components as well. One small specialty about this architecture might be that I also use dedicated infra nodes. However, you can also just ignore them and also run your infrastructure components on top of your regular worker nodes. And if we now take a more detailed look at this architecture, we already see that it's not just like a single component per infrastructure tool. It's often like a full stack of different deployments, daemon sets, and so on. And this isn't easy to manage if you try to apply a near zero trust or a full zero trust approach from a network policy perspective to your Kubernetes cluster. And those are not just any random arrows I put on this diagram. Those are real connections I observed while having a look at Cilium Hubble. So we need a structured way, a structured approach, how we can work towards to a zero trust approach or a near zero trust approach. And here I would generally recommend you to start with network policies as early as possible. Don't wait with implementing network policies until like 1 week before go live, because it simply won't be successful, at least in like 95% of the times. So then I would recommend you to start bottom up with implementing policies. And here I would start with policies for nodes in case you actually want and need that. Then I would continue with like basic Kubernetes communication flows, such as the communication between the kube-apiserver and the kubelets. Next, I would take a look at really key fundamental infrastructure tools, such as the CNI, because without CNI, nearly nothing is really running successfully. And next, I would have a look at infrastructure components, like the more or the less relevant ones, like the monitoring, like logging, and so on. And finally, I would advise you to have a look at the network policies for your specific user workloads to complete this whole stack of different network policies. While doing this, it's always a really great recommendation to have a look and keep an eye on the network flows that are happening within your cluster. And Cilium Hubble is a great tool for doing this, because with Hubble, you can easily filter for like audited or dropped flows. And this helps you to identify false positives or wrongly configured network policies like within seconds. Last but not least, this is kind of a process, not like for once, but it should be done over and over again. And the more you redo this whole thing, you are kind of going to a more refined end result. So let's first talk about how to secure your nodes. Generally, in especially larger, medium to larger enterprises, perhaps you often have dedicated security teams, and sooner or later, somebody from this team will ask you from the Kubernetes ops team, well, we have internal policy about enabling a host firewall on any Linux machine. Well, guess what's usually the first recommendation in any Kubernetes getting started guide? First of all, disable host firewall, and the second is probably like disable SE Linux. So by side of that, there's often also the motivation which is driven from an external standard, such as PCI DSS or an ISO standard. So especially enterprises in the financial industry really need to care about those. And last but not least, sometimes in rather unfortunately rare cases, we also have the motivation from the Kubernetes operation team itself to improve their own security posture by also applying host firewalls, host policies on the Kubernetes nodes. And you can either rely on like more legacy tooling, such as the NF tables or IP tables, net filter tools in general. But else than that, you can also use a more cloud-native approach that is called Cilium Host Firewall, sometimes also referred to as Cilium Host Policies. And those host policies are especially highly recommended for high security environments. Honestly, I wouldn't recommend you to apply those to just any environment, because there's also an overhead, an operational overhead you need to manage if you choose to do that. So there, you need to find the right balance. And in the end, it's for sure a feature. You can do a POC, perhaps deployed on a test cluster, but in the end, you really need to also take care about the operational complexity you're gaining while activating this feature. So speaking of while activating this feature, it's rather simple to activate this if you are already running Cilium. So here you just need to change one single Helm value that is called hostfirewall.enabled equals to true. And as soon as you enable it, you are able to apply Cilium host policies. And we have an example of such a host policy on the right. And this one is intended to be used or applied to control plane nodes. And as you see, it's just like other Cilium network policy. This time it's a Cilium cluster-wide network policy. But at the same time, we are not using an endpoint selector, as you usually do if you would like to select like ports, workloads in general. But here we are kind of using the node selector to actually select nodes. So here we are selecting labels of nodes to apply those rules to. And here in this example, for kube-api, well, for the control plane, I needed to allow the kube-apiserver connectivity on port 6443 TCP. And at the same time, I needed to allow like etcd connections either from the local kube-api server instance, which is running on the same node as this etcd instance, or from the remote control plane nodes, because there's also an etcd instance running, and they need to sync in order to be able to keep the quorum. One very important information there. After you enabled Cilium host policies, the first thing you'd need to do, or what's highly recommended to do, is to enable policy audit mode for the host Cilium endpoint. Because if you forget about this and you apply an incomplete Cilium host policy, you have the chance to lock yourself out of your Kubernetes cluster, or sometimes even of your nodes, so that you're not able anymore to SSH to them. So that's something you need to be careful about. However, this policy audit mode is a great tool for that, to get you started. When we need to or want to apply such host policies, we do not only need to care about the control plane nodes, but as you see in this picture, we also need to take care about other connections, such as between the control plane nodes and like all of the kubelet instances, because kube-apiserver needs to be able to actually reach the kubelet API. And that's required for example, pod log streaming or container log streaming. And we have other connections, such as the SSH connection from our SSH jump server to all of the nodes. Then we have some connections for example, ICMP v4, which is pretty useful for troubleshooting sometimes. And beside of that, here in this architecture, I also deployed external L4 load balancers, and those, of course, also need to be able to communicate to the regarding ports. Either it's kube-apiserver port, or in case of the infrastructure nodes, we have Nginx ingress controller running there on those, here in this case, 2 dedicated infra nodes. And since Nginx is running in host network mode or in host port mode, we simply need to allow port 80 and 443. So we already discussed this policy for the host, for the control plane. At the same time, I created another policy to protect our infrastructure nodes. And here we simply match for another label, for the node role infra label. And here we are allowing port 80 and 443 in order that our Nginx ingress controller can be reached from the outside. Then, last but not least, it's kind of one of the most important one. We also define a host all policy that matches for any node, because we defined on line 7 an empty node selector, which basically means this policy is applied to all of the nodes. And here we are kind of allowing SSH jump server access on port 22. We are allowing ICMP. We are allowing kube-apiserver to reach the kubelet API. Then we are also allowing some Cilium internal stuff, like the health checks between the nodes, the HTTP health checks that are running on port 4240. And at the same time, we also need to enable like Cilium data plane specific ports for protocols such as VXLAN or Geneve, in case you choose to run such an encapsulation modes to kind of provide the overlay for your pod networking, or in case you enable transparent encryption, which can either be WireGuard or IPsec based. Here in this case, I decided to go with WireGuard. You also need to allow this WireGuard port. And last but not least, do not forget about infrastructure components, such as the Prometheus or the metric server that are running on top of your Kubernetes cluster, for them to be able to actually scrape endpoints that are part of the host network. And you also need to take care about those connections within your host policies. So let's continue with how to protect your infrastructure components. And here we mainly need to take care about 3 different things. So first of all, we need to allow any ingress or egress communications within an infra namespace. That's the most easy one. Then we need to take care about specific connections that are either coming from the outside to this namespace, or go the other way around, so egress traffic from your infrastructure component to the outside world. And last but not least, we have this kind of most complex thing where we need to take care about implementing a restrictive static rule set that should be in a generic way that is automatically applied to all new and also removed from the newly deleted namespaces. And those rules should allow specific infrastructure components to reach user workload namespaces. And those functions could be core DNS to provide DNS service for our user workloads. It could be Nginx ingress controller or Prometheus to actually serve or scrape ingress objects or scrape metric endpoints from the user namespaces. And there I would like to create a generic approach which doesn't need to be adjusted whenever I remove or add a new user workspace. And here we are starting with like the first rule, which is the most easy one. Here we are just creating a Cilium Network Policy. As the name already kind of indicates, this is a namespace resource. It is applied to a namespace. And here, since I'm not matching for any endpoints, it simply applies to any pods that are started within this namespace. And because of the empty endpoint selectors within the ingress and egress section, we are allowing everything. Next, I would like to allow only specific ingress and egress communications from those infra namespaces. And here I take the example of Nginx. And here for Nginx, in order to kind of function properly, we need 4 different rules. 3 of them are namespace Cilium Network Policies, while 1 of them is Cilium Cluster-wide Network Policy. And you will see why in like 3 slides. First of all, we define the same allow within namespace policy as we just described before. That's number 1. Number 2 is we need to allow our Nginx ingress controller to be reached from the outside world. Here in this case, I even just used like from entities all, because our Nginx should be reachable from outside of the cluster, of course. But sometimes you also have like services that are running on top of my cluster that need to access via external URL. For whatever reason, an application might want to do that. Here, we also need to define a namespace rule, another one for Nginx, so that Nginx is able to reach the kube-apiserver. And here we see another very beautiful feature of Cilium Network Policies. We have the 2 entities, kube-apiserver, and that's already it. We do not need to take care or handle specific DNS names or static IPs of our kube-api server. We just can use this, well-known entity that's provided by Cilium. And because of that, it's automatically allowed. And last but not least, we have the implementing a restrictive static rule set, so a generic way that doesn't need to be updated whenever we add or remove a user namespace. And here we are mainly dealing with 3 different topics. So first of all, I need to define a generic egress rule that allows our infrastructure components to reach out to a namespace. And at the same time, number 2, I need to take care about the generic rule for the ingress on user namespace level. And sometimes it needs to be allowed the other way around. Think of Nginx ingress controller need to reach to a specific service that is running in a user namespace. So that's traffic originating from our infrastructure namespace. And sometimes we also have the other traffic pattern, for example, for core DNS. So imagine we have a user workload that needs to resolve some DNS domains. And here we are kind of seeing traffic from user namespace originated towards to an infrastructure namespace. And for core DNS, we define two rules. Again, because they need to be a generic rule, we are defining a Cilium cluster-wide network policy. So this policy is simply applied for the first time at cluster creation time and doesn't need to be adjusted anymore afterwards, unrelated to any added or deleted user namespaces. So here we are allowing connections towards to our core DNS pods that are running in kube system namespace, and we are only allowing port 53. And here, one small extra feature we activated is like the DNS visibility of Cilium. And if you add those three last lines, rules, DNS, match pattern, you are kind of instructing Cilium agent to inspect and cache any DNS requests that happened from user workloads. And because of that, Cilium is afterwards able to kind of correlate DNS names with IPs, which provides you additional information when you have a look at the flows afterwards with Hubble CLI or in the Hubble UI. Here we are kind of allowing everything, match pattern wildcard. So that's why Cilium doesn't block anything. However, if you want to restrict your DNS requests, you could also add, for example, star.star.svc.cluster.local for DNS for cluster internal domain names. But at the same time, you could also leverage this same pattern here to only allow like company internal DNS names to be resolved. And on the right-hand side, we have the Cilium Network Policy that basically just allows the ingress connections coming from all of the namespaces towards to the kube system namespace. And here we are allowing this traffic coming from everywhere. However, you could also restrict it a bit more, for example, by using the entity cluster instead of all. This would only allow traffic originating from your cluster. And here we are allowing port 53 as well, protocol any, because we want to allow TCP and UDP-based DNS queries. So we now have the egress Cilium cluster-wide network policy for core DNS that was intended to be applied for every single user namespace. However, for our Nginx and Prometheus use case, we need to enhance this logic a bit because we only want to allow our Prometheus to be able to scrape specific namespaces, and our Nginx ingress controller should only be able to serve specific ingresses from namespaces, ingresses from specific namespaces, and because of that, we need an additional condition there. And the beauty here is that we could also, again, leverage our Cilium cluster-wide network policies, because there we have knowledge about the labels that are configured on our namespaces. And this can then be used for policies such as here. We, again, need two policies, one in ingress and one in egress direction. First of all, on the left-hand side, we have the egress rule that is basically allowing our Nginx ingress controller to reach all namespaces that are labeled with a label called exposed equals to true. For our ingress rule, again, remember, we only allowed our infrastructure component to reach out to the namespace, but this doesn't automatically allow this traffic in incoming direction on the regarding user namespace, so that's why we also need to allow it in this direction. And basically, we are switching the endpoint selector and the egress logic, and we also use that as ingress. So this policy is then automatically applied to all of the namespaces that have this specific label set. Again, for Prometheus, we are basically using the exact same idea it's just another label. This time it's not exposed equals to true. This time it's matrix true. However, those labels can of course be defined as you wish. You just need to be consistent with your labeling on the namespaces. Here we have a visualization of this logic, and as you see, again, if you, for example, follow the green arrow from Nginx ingress controller, we see that we kind of traversing two Cilium cluster-wide network policies, one in egress and one in ingress direction. And this only allows Nginx to reach to this workload because our my namespace XY namespace has the regarding label set. And the beauty of this approach is a generic one. So this means we can even leverage the same approach for our infrastructure namespaces by labeling them accordingly. So for example, we have Nginx ingress controller that should be able to serve UIs or ingress resources, to be more precise, from our monitoring namespace. So we have the UI from Prometheus, we have the UI from Grafana, Alert Manager, and so on. And at the same time, we have our Prometheus that should be able to scrape our Nginx ingress controller metrics that are exposed. Now, let's talk about creating a default rule set for our user workloads in combination with the policies we just applied and had a look at. So here, as a general rule of thumb, I would recommend you to try to transition from a more coarse to more fine-grained approach. So here, try to start with layer 3, maximum layer 4 policies, and work towards more specific ones with additional constraints, such as adding additional ports, layer 4 stuff. But sometimes it's also quite nice to restrict it even more on layer 7, because, for example, with Cilium, you're also able to restrict DNS-specific traffic. You are able to kind of restrict HTTP requests based on the HTTP method or the HTTP endpoint. And because of that, you basically have the option to work towards really a fully zero trust approach. And if you work on that, you basically need to take care about 3 different things. First of all, again, you have the namespace internal traffic, then you have the namespace egress traffic and the namespace ingress traffic. And if you got everything correct, you shouldn't see anything left that's dropped as a false positive while using Hubble Observe. And with Hubble Observe, you're basically seeing like any communication that is happening within this namespace or in general within the whole cluster, because you have like a -- namespace flag to limit the scene flows only to like the namespace name, but you have various other filtering options there, so it's a pretty powerful CLI tool. However, you do not need to use the CLI tool. Cilium also offers a Hubble UI, so you even have a UI for that, where you see the flows and the drops as well. Now let's try to combine those steps with like our previously discussed infrastructure component rules. And there we see that pretty much nearly everything is already handled. So for example, whenever we deploy a new user namespace, we do not even need to take care about allowing our core DNS service to be reached from workloads within this new namespace. We do not need to take care about Prometheus or Nginx to reach this new user namespace. We only need to take care about 1 or 2 specific labels. And however, what we need to take care about is allowing namespace internal traffic, because we already applied like Cilium Network Policy cluster-wide that match any workload in ingress and in egress direction. This essentially already means whenever you create a new namespace, it is a default deny behavior. So not even within this namespace communication can happen. And because of that, you need to reallow that by deploying a new Cilium network policy, as we already seen twice before. So here, if you define a new namespace, you give it a name, you decide which infrastructure component needs to have access to it, and based on that, you set the regarding labels. And finally, you also need to apply this allow all within the namespace policy to reallow communications happening between the different, for example, deployments that are deployed in this new user workload namespace. So yeah, that's already it. Here are a few additional resources I can highly recommend you. Perhaps the most important thing here is that if you want to rebuild something I just showed to you, or in case you want to have a look at all of the policies, feel free to have a look at them on this public available GitHub repository. Thanks.
Really interesting session, Philip. Thank you so much. You received some super, I think, interesting questions. So the first one is, does Hubble show dropped traffic if we use Cilium host network policies at node level?
Yeah, we do. We see both. We do not only see like cluster internal traffic, we also see the dropped traffic in case you enabled Cilium host policies. If you don't enable Cilium host policies, you won't see any kind of drops on node level.
That's very efficient as well, right? When you're dropping traffic at this level.
Yeah, exactly.
Yeah.
Yep.
So the next one is, what are the benefits of Cilium network policies compared to plain Kubernetes network policies?
Mm-hmm. That's also a pretty common question. The thing is, the possibilities with like the upstream default network policy spec is rather limited to layer 4, layer 3 only. And for example, they also do not have those shown identities that abstract some complexity for you as an end user. And beside of that, Cilium network policies also provide additional advanced features, such as the mentioned DNS filtering options, such as from and two-sider stuff, and for example, also layer 7 stuff like rules for HTTP or Kafka and so on.
Yeah, very good. Sorry. The next question is, any experiences with DNS-based network policies? Example, when using an external service, using multiple IPs that may change.
Cilium agent caches those entries. It's also fully configurable how long you want Cilium to cache those entries. And Cilium also inspects like every following DNS requests from all the pods, which essentially means Cilium will get every update you might get from a changed record from an external DNS server.
And the last question is, do I remember right, that you can use Hubble/Tetragon to generate policies out of current traffic?
Yes, you can use Hubble for that, but that's a Hubble Enterprise only feature. That's not in Hubble OSS. And Tetragon is something different that's used for process visibility and not really used for network policies. Yeah.
That's all the questions we have. Let's have one more round of applause for Philip. Excellent session.
Thanks. And if you have additional questions, feel free to come visit us at the Isovalent booth. I will be there.
Yeah, so now we will have a coffee break and a sponsor showcase where you can catch Philip at the booth. And you can also visit the other booths. We'll be back here at 4:35 with the paradigm shift in observability. Ooh.